Okay, in this second video I will show you how to add one diode to the 4-bar mechanism that we just designed. Of course, that is not required by the problem 2.7, but it's required for the assignment that you have at hand right at this moment. So let's go back to Fusion. I will open my Fusion window, and we are exactly there where we finished the previous video. We have this sketch 5, which contains our mechanism, the 4-bar mechanism, which correctly describes the 3 required positions. Okay, so now let's add the diode. Okay, and to do that, we will continue working on this sketch, because we need a lot of the information that it's here. So I won't create a 6th sketch. I will continue on the 5th one. So let's create one line that will define one of the 2 limiting positions for our 4-bar mechanism, and that's one of the requirements, right? Not from the problem 2.7, but we are asking you to add one diode that will make this mechanism to go from its limiting position 1 to its limiting position 3. Okay, passing of course through the limiting position 2, and that's solved already. But creating one diode that will be based on a motor, and that regardless of this mechanism being or not a Grashof or meeting the Grashof condition, that's something else. So we need this line, and the second line will go from the same point to the other initial or how to say that, or final position, limiting position of our coupler. So this will be, in other words, our mechanism. And you will see that if we want to go from here to here, then those are the 2 extreme positions or limiting positions for our link number 2. Okay, and we continue to leave the mechanism at rest on any arbitrary position. Okay, so now we have that, and the next step includes deciding where will I put my diode. In this link, actually I did it already, you know, I should have started there this video, but I implicitly am telling you that I will put the diode on the link number 2. If I decide to use the diode or to put the diode on the link number 4, which is possible, then I would need the 2 limiting positions for that link, and I will create lines from here to here, which I won't do, and then from here to this other point. Okay, so but I am working with the link number 2. So the next step, the next important decision is to decide where exactly in the link number 2 I will connect the diode. And for that I am using very arbitrarily, but we have taken a lot of arbitrary decisions, or engineering decisions, let's say. I will decide to have the diode connected from the origin of link 2 25 millimeters, okay, far from the origin. So I have that, and of course my diode will only work from this line to this other line. So I that's why I trimmed that the rest of the circle. And if you are curious about what is the angle that we are sweeping out with those 2 limiting positions, it's 120 degrees, almost 121 degrees. Okay, so now we have that, and the next step, and actually we have seen these steps. Okay, this workflow was seen at the beginning of our module 2, when we started covering different methods to design mechanisms. So now we have this line, and we will create one circle center on that line, which will have that diameter. Okay, so I tell the software, you know, this is an auxiliary circle or construction circle, and then I create another line which goes from here to here. It's a construction line, and I tell the software, you know, I want this line to be collinear with the first one. Okay, the second, well, maybe the third important decision that we have to take, the first one was if I was going to connect the diode to the link 2 or 4. I decided the link 2. Then how far from the origin of that link? 25 millimeters, right? The next question is where I want to fix my origin for the link number 5. And I will decide just arbitrarily as we have taken all other decisions. So I will create one circle here. This is a construction circle, and we will set the diameter just for this circle. Now I am a little lost. Yes, it's that one. Okay, so we just finished the design of our diode. What do I mean with that statement is that right now the link 2 will have this dimension, will go from here to here. So I could just state, if you want to take note of the dimension, is 21.75, okay, almost 21 and 3/4 of millimeter. And then the other link will go from here to here, and that will measure 85 millimeters. Okay, so that's another decision. These two dimensions arrived from fixing our link number 5, or the origin of link number 5. Okay, and that's what I will do next. I will fix this link or this origin. And now, you know, you could be tempted to create the mechanism or to construct the diode, to take the diode to this original or limiting position, but it will get very difficult to move it from here because this line acts as a reference, like a constraint for the sketch. So instead of that, I will create one circle at this arbitrary point. Okay, since my link will be at this position, or my link is at this position. I am talking about link number 2, the blue one. So I will create, now that I know the length of the coupler of the diode, okay, I can create one circle at this point, center at this point, and having 2 times the length of the diode, 85.522. Okay, and that of course will be another construction circle. How many circles do we have here? We have a lot of them, right? So that defines where my joint between the link number 5 and the link number 6 is at this moment. And with that, I can create this first link, and then this second link. Okay, so that's my diode. And if everything is correct, let me check. My diode should move correctly the mechanism. Okay, can you see that as I rotate the diode, and you can think that we fix one electrical motor here, and then the diode will make our mechanism, the 4-bar mechanism, to go between the 2 limiting positions. So that's what we wanted, and I think this is a great achievement in our mechanism course, because this time we weren't provided with the linkage, but we designed it to comply with a certain application. Of course, the application is like any application, okay, that you can think of. But then we added one diode to take advantage of an electrical motor and move our 4-bar mechanism between these two limiting positions. So I hope that this procedure helps you to design your mechanism. Now, if you want to build, and you will have to build this mechanism, to manufacture it or to prototype it at least, you know that link 2 has a dimension of 21 in my case, and link 5, sorry, because we have a 4-bar mechanism here. Then link 5 has a length of 21.751 millimeters, and the link 6, which is the coupler in the Dyad, should have a length of 85.522 millimeters. Okay, and sorry about it. And with that, we are finishing this project, and I hope that these steps are useful for your own project. Okay, so thanks for watching, and we will see you in class tomorrow. Okay, thank you.